Hello engineers, welcome to a new video on low-level design. In this video, we're going to look at a very powerful pattern called the command pattern. I hope you're ready. Let's get started. So let's start with the intent. Encapsulate a request as an object, thereby letting you parameterize clients with different requests, queue or log requests, and also support undoable operations, right? So the important keyword is to do undoable operations. There can be many applications that require undo redo operations, right? So let's try to see the examples first, and then we'll see how this pattern is used. So all the editors that we can think of, like Microsoft Excel, Microsoft Word, PowerPoint, OneNote, right? Google Docs, Google Sheets, Google Slides, right? Any type of editor that requires undo redo mechanism will keep track of history of all the things that we have done, and it supports undoable operations, right? So in all these type of applications, we will need some kind of a structure to enable these undoable operations, right? So let's first try to understand how it would look like without this pattern, and then we will appreciate the power of this pattern, right? So let's say we have a text editor. And let's say we have one class without using the command pattern. And internally, let's say it is holding text in the private space. And in the public space, let's say we have given bunch of options for acting upon this text. Let's say we have given an option to set it as bold. We have given the option to set it as italic and set underline and so on, right? And let's say somehow we have provided a mechanism to undo, which means somehow we are retaining the history in the private space of each command, right? So let's say this is a typical class without any command pattern. You would say this might work. What is the problem here? But there are a couple of issues here. First thing is this is violating the single responsibility principle, because this class needs to change for every additional command, or if there is any change in the existing command, this class needs to change. So it is having multiple reasons to change. That's why it is a clear violation of single responsibility principle. And it is also a violation of the open close principle. Why? Because it is not really open to extension, right? Because every time we have to come into this class and change something. So that is clearly not closed for modification. It is somehow open to modification. So it is a violation of the open close principle. And if I want to add a new command, I need to come in here. And now I'm dealing with text. What about when I want to deal with something other than text? Maybe I've added a table. Maybe I've added a line, a circle. So these shapes can have their different commands and not text related commands, right? But the editor is the same, right? So editor must be the same, and it should support text, table, diagrams, the handwritten text like this, and different types of shapes and so on. So how do we build one common application that can take care of all this and also provide their own respective commands so that they can operate on their own, right? So what do? We split it up like this. Let's say we take the editor out. We take the text also out. And we take the commands also out. So we split all three into different classes. So editor will just be responsible for calling the commands, execute commands. It will take in a command and execute a command, right? And every command will carry the receiver. So the receiver can be text, receiver can be a table, receiver can be a shape, and so on, right? And because we have separated out a command, we can make this a common interface and extend this to different commands. So for example, text related commands can go here, bold, italic, underline. And table related commands can go here, like add row can be a command. Delete row can be a command, and so on, right? So there can be any number of commands like this, and they are all independent of the receiver. So command can take in any type of receiver and execute its respective action, right? And editor will just be responsible for executing the command. It will just take in a command object and execute and call execute, right? So this way we are keeping it so much flexible. Everybody is responsible for their own actions. Everybody is open to extension. So there can be more type of receivers here, there can be more type of commands here, but the editor will be the same. Like this OneNote editor is just one application, but it is able to support bunch of things: bulleted text, handwritten text, we can add tables, we can insert any type of shapes and so on, right? So there can be a bunch of things that can be done here, and all this will be supported using the command pattern, right? And because editor is on its own, editor can carry the history of each command, because now commands are coming in from an external source. It can keep track of each command, and when we call upon undo, it will just pick the latest item from the history and does the opposite, right? Simple. So this will be more clear once we see the implementation, but this is a high level understanding of the command pattern. We are able to separate out the responsibilities into different classes so that we are open for adding new types of objects and adding new types of commands which can operate on their own, which can grow on their own. So that is the power of the command pattern. And not only that, we can even combine commands. There is nothing stopping me from creating a new command called bold italic. This can be a new command on its own, right? And there can be a new command called italic underline. This can be another command. So we can combine commands and make it even more powerful. So for the editor, it will just be another command which will just go into the history. And if we undo it, both italic and bold will be undoed, right? So that way we can create a very powerful structure using the command pattern. And that way we can create a very powerful structure using the command pattern, right? So let's see how this pattern actually looks like. Let's try to understand with UML diagrams. Let's go to UML now. So this is the class diagram representation of the command pattern. There are a bunch of things here. Let's have a look. First is the invoker, which is our editor, right? The application. And it will carry one method called execute command, and it will carry one method called undo. And it holds the history of each command. So this is an array of commands, right? And what is a command? Command is a common interface which can be implemented by multiple commands, right? So this can be command to make it bold. This can be command to make it underline. There can be another command to make it italic and so on, right? There can be a bunch of commands, and each of the command can be given to the invoker, and invoker will add it to the history and call execute method. Where is the execute method? In this interface, right? So in this interface, there are two things: execute and undo. Executor will call this execute, and this execute will call the receiver action. And who is the receiver? Receiver can be anybody. It can be a text, a table, it can be a shape, and anything like that. And it will have its own state. If it is a text, it will have states like, is it bold? Is it underlined? Is it subscripted, superscripted, and so on, right? And when we say execute, for example, our first command is make it bold. So we will say text dot make it bold, and it will change the state of the text, right? And so on. So there can be any number of commands like this, and each of them will have its own action. This action can be part of the receiver's class, or it can be some logic that even the command directly executes, right? And similarly, there is an undo method. Undo method does the opposite action, right? If the receiver is giving a function to do the opposite action, we will just call that function, or it is the responsibility of the command to enable undo of that operation, to do the opposite action. For example, what is the opposite of is bold? To make it not bold, right? It is just a toggle, right? So just like when we call execute command on the invoker, it will execute the execute method from the command. When we call undo, it will just take the last executed command and calls the undo on that command, and it will do the opposite action, right? So quite a powerful implementation when we separate everything out into their own classes, right? So this is a class diagram representation. Let's see the sequence now. Okay, so this is the sequence diagram. So client will create a receiver, will create a bunch of commands, and will create an invoker, right? So in our example, receiver is text, commands are bold, italic, underline, invoker is our editor, the text editor application, right? So this is how it goes. First, we call execute command using command A. Command A can be, let's say, make it bold. So the invoker will call execute on the command A class. And internally that execute method will call on receiver's action. So receiver is text. Now the text will be changed to a state that it carries bold state, right? So this is where the actual change is happening, but it is getting invoked by two layers, first at the invoker level, then at the command level, right? And then the client can choose to call the undo method. When we call undo, the invoker will fetch the latest command that has been performed and calls upon undo for that, and the receiver will do the opposite action on that. So this is the sequence, right? So quite a interesting sequence. Let's see an example now. Let's build a simple text editor that we have been talking about. So first we have the text editor, which is our application, which will hold the history of all the commands, and this will have an execute command method which will take in a command and calls upon execute, right? And then it has an undo method which will pull out the latest command and calls undo on that command, right? And what are our commands? There can be three commands as given in this example. There can be bold, italic, and underline, and the receiver is a simple text, right? So the text has three states: is bold, is italic, is underlined, and it is giving three functions to act on them: set bold, set italic, set underlined, right? So these are the setter methods for acting upon these states, right? Next, so let's say we have the bold command, and inside the bold command's execute method, we will call set bold for this text and pass the boolean value true. When we call upon undo, we will call upon set bold on the text and call it with the false parameter, right? So this way we are able to change the state of the text using the given setter methods, right? So this is the idea behind the command pattern. So we separate out the editor from commands and the receivers so that they can grow on their own and they can build their own commands and their own setters and getters to operate their own state, right? Quite a powerful implementation. So let's see all this in code now. So I'm in VS Code now, and we now have a new file, command.cpp. So let's see them. First, let's talk about the text. It has three states: bold, italic, underline, and it is giving three methods to operate on this state: set bold, set italic, set underline, and one method to just print out the current state, right? So this is our receiver class. Now we have a command class, which is a common interface. It has two things: execute and undo, right? And this will be extended by bold command, italic command, and we will also see an example of a composite command in a bit. Let's look at bold command. So bold command is implementing the command interface. So it will have its own implementation for execute and undo. So what is it doing? It is calling upon the text receiver and calling set bold to true. And when we do undo, it is calling set bold with false, right? It's very simple implementation. Similarly, italic will have set italic to true and set italic to false, right? So these are the execute and undo methods for this command. Similarly, we can combine commands. For example, I can create a composite command which will hold a vector of commands. So when we want to add a command, we'll call add command method and we will add command to it. And when we say execute, it will invoke a loop for each command in this list, in this vector, and call upon execute for each of them, right? And when we do undo, we will do the opposite. We will start from the reverse and call undo on each of the commands. So this way we are able to create powerful composite commands and make use of them in our text editor. Now let's look at the editor class. So as we discussed, editor will hold the history of commands, right? So for every command, we will just push back that command to this history. And when we do undo, we will pull out the command from this history and then call undo on that. These are the two methods. First is execute command, which will take in a command and calls execute, and we'll add it to the history. And when we call undo, we will bring out the latest command from the history vector and call undo on that and then delete it from the history, right? Very simple and powerful. This way editor is clean, right? It is just having two methods, but it is not bloated like we saw in the first example where we put everything in this. The bold, italic, all the commands we try to add in this, and this was a bloated class. Now this is a simple class, right? And it is very independent and decoupled from the commands, right? So this is a great flexibility. Now let's see the usage. First we have the receiver, the text, then we have the invoker, the editor, and we will call upon execute with commands. So first we'll create a bold command Then we'll create an italic command and pass it to execute. Execute command will call upon execute method on the command, right? So currently the text state is, it is bold and italic. Next we have the undo methods. We will call undo first. This will undo the italic because italic was the latest command that was invoked. And then we'll call undo. This will call bold commands undo. And so now our text is back to the original state. And then with this example, we can also combine a new composite command with bold and italic together. So we are adding two commands to this composite command, and then we're calling execute on the composite command. So it will go through a loop and execute bold first, then italic first. And then when we do undo, it will do the reverse. It will undo italic first and then bold first. And then we will get our text back to the original state, right? Let's run this and see. So as you can see here, when we called bold first, text is now bold, then text is now bold plus italic, and then we called undo, so now italic is gone. Then we called undo again, so bold is also gone. Now text is in the original state. And then we use the combined composite command for bold italic. So there is a loop that is running. First bold is applied, then italic is applied, then italic is removed, then bold is removed. So text is back to the original state. So like this, you can imagine any number of commands and they can be executed at runtime, right? No problem. So this is a code implementation of the command pattern, right? Now let's see some trade-offs. So with the command pattern, like we discussed, there is a great decoupling between the invoker, the receiver, and the commands, right? So it follows the single responsibility principle because every class is operating on its own, and it is also following the open close principle because every class can grow on its own, right? So there can be multiple commands, there can be multiple receivers. And this also enables undo redo because we are saving the history for doing the undo. So what do we do for redo? We can create another vector like this which holds the list of things that were called in undo. And when we call redo, we will just pop out the latest undo and then call the execute on that again, right? So we can have the flexibility like this. And then it also supports complex commands. We can combine commands and make them an even powerful command. So that way we can create complex commands, right? So coming to weaknesses, because we have separated out everything, we need to deal with a bunch of different classes. So the complexity has definitely increased. And we also need some more memory to manage the history. So you can keep on clicking undo, undo, undo until you reach a point, right? So that way we need additional memory to keep hold of things that were done to the object. So these are some things to keep in mind. Okay, I think we have covered a lot in this video. We have seen a very powerful pattern called the command pattern. We have seen the intent, we have seen the examples, we have seen the UML diagrams, the code walkthrough, and also some trade-offs. So the code and UML diagrams are linked in the description below. So definitely check them out, give it a try so that you can play around with different commands and change the diagrams to see how you can implement it for maybe a table, right? Add a table and then try out the different commands for the table, right? That's it for this video, guys. Do leave a like if you found this helpful. Do subscribe if you haven't done already. Thank you so much for watching, and I will see you in the next one. Cheers.